Okay, let's do one more. Same question, but now with a system of three equations. Alright, so the first thing we want to do is write the augmented matrix. Alright, so I'm going to hit pause and do that. And I encourage you to do so as well. Okay, so there's an augmented matrix that could represent the system. Alright, and now we want to go put it in row echelon form. Alright, and to do that, we're going to do some row operations. So I'll hit pause when I do the operations, like the nitty gritty, but what I'm going to do is I'm going to move equation 3 to the top row, because that has that coefficient of 1 there, which we can use to add to other equations. Alright, then I'm going to add equation 1 to equation 3 to eliminate this first term here. So 1 plus -1 is 0. Alright, and then also take 4 times equation 1 and add it to equation 2, so that I can eliminate this first 4 right here. Alright, so my goal is to eliminate one variable at a time, just like elimination with systems when it's not a matrix. Alright, so my goal is to get this first row to be 1, 0, 0. And then after that, I want to get a 1 there and a 0 there. And then after that, I want to get a 1 there. And then these other numbers here will tell me what x, y, and z are. Okay, so after doing those row operations, I now have this matrix. So I got my column of 1s and 0s here, and a bonus. Alright, if this didn't happen, I would have to do more steps, but a bonus is that this y also eliminated. That was because when I added equations 1 to equation 3, like those canceled out and those canceled out. So now I have this matrix here. You could express it back as a system of equations like this. Okay, now this isn't in row echelon form because, right, we don't have that row of 1s, that diagonal column of 1s like this. But if you just switch these two and then just divide everything here by -6 and divide everything here by -25, then it would be in row echelon form. So once you get those zeros in to the left of the diagonals, then you could put it into matrix form and then just do back substitution to solve. Alright, so from this bottom part, you would get z is equal to 3. Alright, then if you plug 3 into here, alright, you would get -25y equals -48, or -48 equals 27. Right, and then you would solve for y, and you'd get that y is -3. And then when you plug y and z into this top equation here, you would get that x is equal to -2. Alright, and you can also do that just by continuing to do these types of operations, alright, until you got down to an identity matrix as a coefficient matrix, and then this last row would tell you what x, y, and z would be. Alright, so now I'll just show you how to do that on the calculator. But that's how you would do it by hand. Alright, so to do it on the calculator, I'm going to open up a new document, a new calculator, and then simply just type in the letters R, R, E, F. All the buttons that you need, if you forget, you could hit this book button, and you could find R, R, E, F somewhere as one of the functions. There you go, there's REF. I guess it's not down here. Well, that's row echelon form. So, yeah, there it is, right there. If you wanted reduce row echelon form, then you could type in 2 R's. So let's just do REF for a second. Alright, and then I'm going to type these numbers into the matrix. Alright, so I typed in the original augmented matrix and I hit row echelon form, and oh, that's incorrect. So I could tell this is not right because it says 1 equals 0, which tells me that z, well, I guess z could equal 0, but, so I take that back. But there's a mistake. Now we're good. Alright, so this is just row echelon form. So this is what we got after I did the row operations, and then if I were to divide everything by 5 and -3 to get these diagonals of 1s, that's what it would look like. Then we could do back substitution to solve. If you do RREF, it'll get it into reduced row echelon form, and now you know, okay, x plus 0 is -2, y is equal to -3, z is equal to 3. All right, and then if you wanted to check it again, you can even do algebra, solve systems of linear equations, and then do 3 variables, and then actually type this whole equation in here in these 3 spots, and you would get the same answer.